Okay, thank you all for joining today. A reminder that the public webinar series is designed to educate attendees on the scientific ecosystem, and each month we'll have a representation from a center or program and partnership with new developments that support them. So today I'm going to be going over a few updates, some upcoming events, and then we'll hand it over to our featured speaker. Just a reminder that all of our webinar recordings are available on our YouTube, so please feel free after the session to share this with your colleagues, and also can go back to see any others that you may have missed in the process. Just as a general call for feedback, questions, or if you'd be like to be added to our listserv, please email us at help@cfdeknowledge.org. Just some upcoming events that are going to be going on within the ecosystem. On Friday, May 9th, there's the virtual symposium on 4D nucleome single cell for all. And this is going to be led by the Center for Epigenomics at UCSD and 4DN. This is virtual, and you can check out their website for all the information regarding this event. And then two conferences that CFDE is going to be represented at is the Intelligent Systems for Molecular Biology, July 20th through 24th in Liverpool. And as always, the American Society of Human Genetics in October here in Boston. We'll have some more information regarding these events as we get a little bit closer to. But this year we'll also have an ancillary session and a booth at ASHG. So we look forward to seeing you all there if you'll be at these events. One thing that I'd like to highlight here, the Decoding the Data Ecosystem is a CFDE Training Center podcast. And I just want to note, it's not only just a podcast, it's actually a community for anyone passionate about the potential omics research to solve complex biological puzzles and addressing pressing health challenges. So this could be for you, whether you're a seasoned researcher, you're a brand new student, or you're just curious about biology. And this podcast has valuable insights, inspiring stories, and practical advice to guide you through omics research, training, and education. And actually is led by Dr. Allissa Dillman, who we have with us today, who will be presenting. But I just wanted to shout out these episodes. There are 4 that are up currently. So if you check out their resource, there are 4 episodes, like I said, featuring Noelle Burt of the Knowledge Center, Dr. Anne Dislatz-Mays of Kids First, Jennifer Burnett from the Training Center, and Dr. Shankar Subrahim from the Data Resource Center. These are all extremely well done podcasts. We also have a link to them on our KC as well. So if you have a moment to take a listen, we highly recommend that you do so. And with that, I will now be handing over the session to Allissa, who, as I mentioned before, is from the Training Center. She'll be walking through hackathons with impact, data-driven projects within the CFDE. As I hand this over, just a reminder that please feel free to use the chat or Q&A to ask questions throughout this session. We'll be monitoring it throughout. That looks great, Allissa.
Okay, excellent. Thank you. I just wanted to make sure I had the Q&A session open if anything pops up, so hopefully I can see it too.
I will also be monitoring it, so I can pause if need be as well for you.
Awesome. Okay, thank you so much. Okay, so today I am really excited because I get to talk about my favorite topic, which is hackathons. I've actually run well over 60 of them now, and honestly, I've kind of lost track. So I'm always really excited to talk about these events because they're just super fun and also super impactful. So today I'm going to talk a little bit about hackathons in general with their impact, specifically on data-driven projects with CFDE. So for today, I'm going to have sort of 3 main objectives that I'll get through. So first of all, I want to kind of set the stage for what hackathons actually are, because they can be sort of done in a lot of different contexts in a lot of different ways. So sort of defining what they are, and motivations behind them and things like that will hopefully kind of give us an understanding of these kinds of events. Then I'm going to also share sort of the brief history of the BioIT open source and fair data hackathons, because we've actually had 5 of them. And then I'm going to specifically talk about the 2025 event that just happened last month, and what those successes and lessons learned were. All right, so what actually is a hackathon? This is going to be kind of my definition, but I'm also going to share a broader definition in a second. But for me, I think of a hackathon as basically somewhere between a 2 and 4 day marathon. And the idea is to build tools and answer meaningful questions of interest to a particular community or set of communities. These events can be open to specifically to subject matter experts, but they can also be open to broader audience that include enthusiasts as well. And really sort of at the heart of a hackathon is this idea of, expertise sharing. You have a diverse audience, so you can share all sorts of expertise. You get to learn together, you get to collaborate together, and you get to have like this very creative problem solving space. And I like to think of hackathons as always having 3 components. So I have my hackathon triangle here, because for me, every hackathon has all 3 of these components. The first being the one I think people are most familiar with, and that's the creation aspect. So most of the time when people think of hackathons, they think of some people building, some sort of analysis pipeline or tool or wearable, like something that is being built. That could also be things that are a little more broad. So they could be things like building knowledge bases, building infographics, building art. They could be building training resources. But the idea is every hackathon has some sort of aspect of creating some output, whether that's sort of a physical output or a software output. Like I said, the other strength of a hackathon is this idea of collaboration, that you're really engaging with a lot of different communities and people of different backgrounds and education levels kind of coming together to think about things in creative ways. And then I always think of hackathons as having an education component as well, and that can be both formal, where the organizers are trying to share information about a particular data set, resource, scientific topic. So there's sort of like education from us as the organizers, but there's also peer-to-peer education. Oftentimes you're working alongside folks you've not worked with before, and you're sort of sharing like resources and tips and tools and things like that in your particular field to others in your team. So every hackathon has all 3 of these components. But the reason why I have them in a triangle and I kind of have these arrows is because I do think that while every hackathon has all 3 components, each hackathon sort of weights towards one of these components a little more than the others, right? So if your hackathon is really focused on making a thing, you're going to really kind of lean into that creation aspect and make sure that there are a lot of on-ramps to building the thing, whether that's like compute space or physical maker space, right? Like some sort of place that makes it very easy to do that creation. Sometimes for hackathons, we care the most about collaboration, right? Like we have this very niche thing, a very niche community, and we really want to kind of open it up to others to explore. So then we're really going to lean in heavy on that collaboration. And we're going to expend a lot of our resources trying to making sure that we're getting really diverse engagement. Other times, really the focus of a hackathon is just mostly to have people be more aware of a thing that we've created or put resources into. And so then we're really going to lean heavy into this idea of like education, where we're going to have like lots of pre-hackathon webinars, and we're going to have lots of wikis and all sorts of documentation to really make sure we're getting folks more educated on a particular thing. Now, I also happen to be part of a global community of hackathon organizers, participants, and researchers from across academia, industry, nonprofit, and government. And we actually all come together once a year and we do a workshop where we really share tips and tricks, best practices, and we really discuss how humans collaborate and specifically how hackathons help us solve important societal problems and support community-driven environments. And so we've kind of come together to try and create a definition for hackathons because we all run them in different ways in different spaces. So our group, our workshop that we run every year is called Hack the Hackathon, and you can kind of see our definition here. But this is sort of basically a even broader definition than the one I've defined, right? The idea that hackathons are this time-bound, participant-driven events that are organized to foster specific goals or objectives, and that the people participate in the event have different backgrounds and bring different expertise, and their primary motivation is really to join an event, is to work on shared team projects that interest them. And during the event, teams attempt to create some sort of artifact that are shared with other participants, right? So that's sort of a really all-encompassing definition sort of in our field of hackathons. So when we're talking about hackathons, really the driving force of them is this idea of community-driven engagement. And that comes in sort of two flavors, or almost like two spaces. First is this idea of crowdsourcing, sort of just like writ large. And crowdsourcing is this process where individuals or organizations can submit an open call for voluntary contributions from a large group of unknown individuals, which is the crowd, hence crowdsourcing. Sometimes it can be a little more focused, where there's sort of a very specific group of trusted individuals or experts, but it's still sort of people outside of your normal everyday work. And you're really looking for, opening up that space a little more. And another sort of aspect of, especially like in STEM, hackathons and community engagement is this idea of citizen science. And this is a form of open collaboration in which members of the public participate in the entire scientific process. So everything from identifying research questions to collecting and analyzing data, interpreting results, and solving problems. So really at the heart of hackathons and this idea of community engagement is really about from public curiosity all the way to expert insights. Crowdsourcing and citizen science really unite people to help fuel discovery and shape sort of future drives of a particular field. So crowdsourcing specifically in a hackathon, because you can do crowdsourcing in a lot of different ways. You can do crowdsourcing in challenges. You can do crowdsourcing in completely online asynchronous platforms. But crowdsourcing in a hackathon can come in sort of come from two avenues. So first of all, from project pitches. So you have a hackathon, you've kind of decided on a theme, and now you're interested in what are the actual questions in this space. So you can actually ask the public directly for their ideas on all the way from a very broad field to a very specific narrow topic. It kind of depends on what your motivations are for a hackathon, whether you want to sort of have it be very open-ended or you really want to focus on a very specific question or topic or resource. But at the end of the day, you're basically saying hey, what kinds of questions would you have if we're talking about this specific topic? And by crowdsourcing, you can really learn quite quickly about common problems in a particular community, depending on which communities you're having this open project pitch call to. You can also get more ideas for interdisciplinary approaches because folks who are interested in participating in a hackathon know there is this idea of very diverse backgrounds coming into these events. So oftentimes they pitch projects that they wouldn't necessarily do, for instance, in their own research lab because they may not have expertise in Y or X or Z, but they are excited by the idea that in a hackathon, I might actually have those sorts of folks on a team with me, and I have this great idea that I can now tap into because I have expertise to explore this particular problem, this particular way. And it also gives a great space for risky ideas, right? Things where you're like, hey, wouldn't it be great if we could do blah? Or wouldn't it be really cool if, we could explore this? And these ideas that are not necessarily as bounded in, I'm going to write a, grant proposal and I'm going to work on this thing for 10 years. It's a really exploratory space to see what kinds of things are even possible. Like this is great for almost like possibility testing. Like, I'm going to do 10 different projects in a hackathon and they're all going to be kind of crazy ideas and, two or three of them will really stick and they might be things that we're really interested in moving forward with. So that idea of like not just beta testing like software or beta testing hardware, but like beta testing ideas. Like how feasible are these things if we've got enough diverse backgrounds in the room to really explore them. We also get, crowdsourcing literally from the participants themselves, right? So if the hackathon is open to, a very large public, then, you're going to have a wealth of different backgrounds, different skill sets, different approaches from each one of the participants. And because we sort of pre-build the teams, we can make sure that each team has, that diverse set of backgrounds and skills. But we can also make sure that hopefully, because we're getting these project pitch ideas, we can really kind of figure out, okay, we're going to need this expertise and this expertise and this expertise to make sure that this project is a success. So sort of building those teams out, make sure that you have that all of these interdisciplinary team. So that's how you end up getting crowdsourcing sort of twofold, right? You're getting crowdsourced ideas, but you're also getting crowdsourced, tools, techniques, skills from across communities. And the reason why crowdsourcing is so useful in a hackathon setting, the reason why we utilize crowdsourcing in hackathons is, if you have participants from various communities and they all come together, as I mentioned, they bring their, all of their knowledge, their skills, new techniques, new tools, new resources in their own respective fields, and now they're applying them to new fields. They will also approach data and tools with, I just want to say, like an open creativity because they're not necessarily bound by the current accepted norms, right? If you are working in your niche field, right, sort of like, these are the core concepts, these are the, the really important findings, these are sort of the accepted things in the field. But if you're not in that field, on one hand, you have a lot of things you need to learn about that space, but on the other hand, you're kind of not bound by any of those preconceived concepts. You get to just explore. And that can be, sort of one of the really unique and powerful aspects of a hackathon that really, you don't see that as much in any other kind of event. If you really have a truly diverse, group of folks with different backgrounds. The other thing is, these interdisciplinary teams that we build really tend to have these new creative solutions, right? So you've got your diverse expertise, you've got this, cutting edge techniques. You've got these novel use of data and tools and scientific approaches. And really at the heart of it, like I said, usually in a hackathon, you want some, creative solutions. So if you really build out a hackathon with all of those components, you're going to get these really creative solutions. The other thing that's kind of cool about hackathons is they're a little bit different than sort of maybe, let's say, a traditional conference where, you sort of listen to talks and maybe a couple of people ask the speaker something, but more often than not, like quite, the majority of people going to a conference are just kind of passively receiving information versus here, like everybody is participating. And it gets people really excited about like the things they learn. And so all of a sudden you have all of these folks like outside of your normal user base that end up being champions for your resource, your tool, whatever it is that you're running a hackathon on, because they themselves got to use it, got to learn it, got to explore it. And now they're going to go back and be like, hey, I learned this really cool tool at this hackathon. Like I want, my team back in my field to use it. So you really get these community champions as well by really tapping into networks outside of your normal communities you work with. So it's also helpful, like if you're running a hackathon or you're interested in running a hackathon or interested in participating in a hackathon, it's really useful to understand the motivations of the participants as well to really ensure that their interests are taken into consideration when building the event. So I really like to try to, remember my mindset of when I used to participate in hackathons and run teams in hackathons when I was still a graduate student. Why are we motivated to do these things, and what kinds of things can I build into a hackathon to make sure it taps into these motivations? And it kind of comes from two angles. So if you're already sort of in a technical field and you do a lot of coding, um, you may still end up being like the only person on your like particular like let's say lab for instance like that is a coder. So oftentimes like you have labs and you've got like a whole swath of like wet bench folks, and then you have like one computational person, and so they're often kind of coding just on their own by themselves. And so people get really excited, especially in like bioinformatics hackathons, to like code as part of a team, like to understand what that looks like, to learn more about like good coding practices, because usually when you code for kind of just yourself, you don't necessarily like think more about like when I share this code, how is it going to be received? But then again, a hackathon, all of a sudden, you're constantly sharing code back and forth and talking to each other. So you really kind of learn pretty quickly which things are useful and not useful. Also, a lot of these hackathons, are really about like large data sets and moving through them very quickly, right? I said somewhere between 2 and 4 days. So if you've got a massive data set, you need to really appreciate very quickly like how to handle that big data, how to have good data stewardship. Um, a lot of folks are also, could be sort of more on the subject matter expertise, the bio side of things, and maybe they're interested in, they've dabbled a little in the computational side, but they really want to learn and beef up those skill sets, so they participate. Um, People also just really enjoy creative new applications of skills, right? We often kind of get into a rut where we sort of, use the same pipeline, the same thing. We kind of do it over and over again, or we're always looking at the same, specific, um, model system, or we're kind of always in that space. And so kind of getting outside of that space and applying our skills in a new question is really exciting. You get to learn about new topics in general. Also, like a lot of people who are more on the tech side of things, like especially, you get software engineers and data analytics and business folks that do coding, that are really excited about applying their skills for good, right? Like the idea that they might be able to impact public health in a small way. Also, like, participating in a hackathon and running teams in a hackathon, you get like massive amounts of leadership experience on the fly. Because you're like running this whole little team and everybody's new, and you got to kind of like navigate using a lot of soft skills as well, because they're people you've never worked with before. And then finally, people just really love hackathons because it gives them a chance to network, right? Like you are now meeting somewhere between 50 to potentially 200 new people, and they all have different jobs and different things, and you've now got them in your network. On the flip side, it's also helpful to know what organizations can get out of a well-structured and thought-out hackathon. So obviously, the big one for a lot of folks is really getting that, novel software and tool creation. That's the big one. However, you also get all sorts of other cool things out of a hackathon. One of my favorite things about hackathons, even back when I worked at NCBI, was really this idea around watching your user base live. Like, play with your data, play with your software, play with your tool, see what happens, see where they get stuck, see what they enjoy the most, see what things they gravitate towards, see when they use a tool like your tool but not your tool, and you can kind of like ask them questions and get more information on why they picked the paths that they picked. So you really get like a cool amount of insight into understanding like what users potentially do when you are not looking. um, you also get to promote whatever data sets that you have, right? One of the biggest things about, especially if we're talking about like computational or bioinformatics focused hackathons, usually there are all these cool scientific questions, but we need data for them. So if you can like already have that data ready, and be like, hey, if you're interested in this scientific question, we already have a data set for you. If you're interested in this, we have a data set for that too. Or, even for tool building, like you want to build this really cool new tool. All right, we have the data type that you can test with that tool. So you really get to have your data sets shine. You get to promote them. The other thing is, it can be really helpful to have, people from all sorts of different fields come together and work because you can kind of build community standards. Oftentimes we think about standards and we're sort of discussing them and building them in these very niche communities, which is not necessarily a bad thing, but like it means we can kind of miss edge cases and miss other ways that people might use a standard. So like having a whole community kind of engaged in building those things can be really helpful. Obviously, you get to have new collaborations, right? Because they're not just collaborating with each other; they're also collaborating with, whatever the organization entity is. So you get to build out those relationships as well. And then finally, in some kinds of events, even if they're not like necessarily about building educational materials, in the longer style hackathons, like the 4 or 5 day hackathons, we actually get people to produce things that are pretty much almost done. And we can actually like utilize those for educational projects as well. So hackathons can be applied to a large swath of questions, and I've run hackathons on everything from, like I said, sort of, maker spaces, wearables, art hackathons, music. You could basically kind of run a hackathon on anything. But obviously, for the purposes of the talk today, I'm going to focus on sort of these bio hackathon themes. But it's still quite a broad, and this is certainly not exhaustive, but these are just some examples I've kind of pulled from previous hackathons. So you can do things like image analysis, and this could be like microscopy or even clinical imaging. We have whole hackathons or just teams on hackathons where they're really focused more on, helping to make the analysis and tools more beginner friendly. So we build like tutorials, we have automated containers and workflows, we have, computational notebooks like our Jupyter notebooks. Sometimes we just do like a knowledge collection of like, hey, you want to learn more about single cell sequencing? Cool. Here's like a bunch of tutorials. Here's a bunch of data sets. Here's a bunch of tools. And things like infographics where people can learn more about a concept in a more visual way. Omics analysis, which is obviously what we're mostly focused on at CFDE, because that's the sort of the bulk of the data, and that's everything from single cell, proteomics, microbiome, and beyond. I have sort of a group I kind of generally call data science, where they're not necessarily as focused on like a specific biologic question as much as they're focused on tooling, trying to generate more automation or trying to auto-generate visualization or, just integrating more machine learning or AI algorithms and building out models in that way. You've also got things like text mining, and NLP, and this can be everything from trying to pull data from metadata, publication data, clinical data. I mean, data is everywhere, right? So sort of pulling out that data and building models. And then we also have things like hardware where we're building like health wearables and even things like laboratory robotics that automate the, the sample handling of things. As I've kind of mentioned and probably already iterated many times because I'm particularly passionate about this aspect of hackathons, but the approach to running a successful hackathon, at least for me, is first and foremost really about like that engagement of a diverse group of potential participants, and building up champions in each community who will share and support, the work that you're going to do in that hackathon, like really broadly. And so if you really want that diverse group of folks, like usually collaborating with different community partners to get those different communities is really important. And here I'm just showing a couple of examples. So for instance, you can partner with an academic institution, especially those that are champions in a particular field of study. That might be what your hackathon is focused on. You can also collaborate with coding communities to make sure specific technical expertise is present. So if you've got a lot of models, women who code is great. If you've got like specific, lots of R, you want to make lots of R packages or Python packages, like partnering up with Our Ladies, PyLadies. These are both local and international groups. So, collaborating with those groups. Finally, also like co-locating with a particular conference can be a great way to tap into particular expertise or communities that frequent those conferences. Obviously, the one that I'm going to talk about in a bit is BioIT World, and that's a pretty heavy mix of both sort of the technical side of things and life sciences. If you are really interested in running a single cell hackathon, there are definitely single cell conferences. So like, making sure that you're like co-locating with that conference means you've already got a whole bunch of experts that happen to be co-located, and you can just kind of like tack your event on. So let's talk specifically about the evolution of the BioIT World Hackathon. So the BioIT World Hackathon has its first year was in 2017, and it's always either just before or kind of partially during. We played with different ways of running it, but it's definitely in some way co-current with the BioIT World Conference and Expo, and it's always in Boston. The first year was in 2017. It was a little bit of a pilot. I don't have too much info on that, but I think starting in 2018 is a good starting point. Partially because that year we partnered with GoFair, the GoFair initiative. So this was an initiative originally with France, Germany, and the Netherlands, and they were really focused on this idea of coming up with rules and questions around like how can we actually measure fairness in data. So we were really focused on fair data that year. We also used a Netherlands-based tool from Purple Polar Bear to actually help us assess the fairness of multiple data sets and data portals. And I actually have the examples here. So we had a team that looked at CBioPortal, the single cell portal from Broad, BioSE protocols, and then Jax looked at their data sets from PDX and mass tumor biology. And it was really about the question of like assessing the fairness of these data sets and portals. The next year, we kind of kept ramping up this idea of fair data. We had a really good discussion where we did also start to kind of think about not just fair data, but also software. So we had like a discussion around this particular article on, the top 10 fair data and software things. And then we also had, this year we had, or in 2019, we also utilized the Fair Shake toolkit, and you can actually find that on the CFDE workbench. And we use that tool to evaluate the fairness of research digital resources. So we had quite a few teams that were still sort of trying to assess the fairness of their resources. But now we also had a couple teams kind of creeping in where they were interested in exploring open tools around those data as well. So we have a couple of teams here that are really looking at, can we verify apps, for instance? In 2022, we really shifted to focus a lot more towards this idea of like open source solutions. So we had, 4 different teams, and we had tools like the Alpha aggregator from NCBI. We also had the NCAS translator, and it was really about getting more, exploring more about this idea of like open source and how we can improve open source tools. And how that integrates with open data and kind of, using both of those concepts together well. In 2023, we really settled on the idea of the interplay between both. So we really were focused on both fair data and open source tools. And we had projects that utilized, both open data, such as Kids First and Includes from CFDE, but we also were looking at tools like Pebble Scout, KidSides, and the Terra platform. So we had 5 different projects that had scientific, that was the first year that not the first year, but like we really started to look at specific scientific questions in the concept of like fair data and open source. So we really started, thinking about like, okay, now that we really got kind of a handle on measuring, open data, open source platforms, like now let's see if folks can kind of like bring in those concepts with, specific scientific questions that they're interested in. That brings me to this year's event, which we at the CFDE Training Center help facilitate. So I just want to kind of walk you through a couple of things I wanted to highlight in the event itself, and then I'll talk a little bit about the projects. So first of all, we had an excellent presentation by Dr. Noelle Burt from the Knowledge Center, and she introduced the participants to the CFDE. So sort of like the concept of the CFDE, what kinds of tools, what kinds of data, and what are the goals of CFDE. So really sort of a introduction to CFDE as a whole. We also had a presentation from AWS about the AWS Open Data Program. And we also had a presentation about the Fair Maturity Matrix Assessment Tool from Pistoia Alliance. The idea was like all of these presentations would help orient the participants and give a flavor of resources both inside and outside CFDE. So that way they could kind of, see what things fit where, as well as like, whatever it is they're bringing to the table. In the hackathon this year, we had 5 teams and 4 directly utilized CFDE data. And so I'm just going to kind of briefly talk through each of these. So the first one I'm going to mention, they actually took data from MotorPack. And so they used MotorPack data to look at exercise resilience. And in the process, a lot of what this team explored was whether the data was machine learning ready. They had a couple of machine learning experts on the team who did not do anything with biology and didn't know anything about, CFDE. And so it was really cool to sort of see, those folks like puzzling through the data and being like, okay, I'm used to finding, this kind of metadata. I'm used to this kind of structure of data, or I'm looking for X, Y, and Z. And to have folks from MotorPack on who ran the team, like kind of, be able to say, oh, actually it's here. Oh, that's really interesting. So that was really cool. Next, I want to highlight the team that utilized the Glygen data. So they made strides in an atlas that basically connects expression data with pathway dysregulation. Next, we have a team that used data from HubMap. So they focused on utilizing machine learning to predict kidney disease from histology whole slide images. So that's our HubMap project there. And then we have another team that used drug central data from the IDG collaboration, and they combined that with data from other places like Cosmic and Lynx. And the idea is they were trying to pull in data, a bunch of different types of data from a bunch of different types of sources to try to optimize cancer treatments. The final team was actually a community pitch project, and they did not directly utilize CFDE data, but it was omics-based data. And they did end up tapping into CFDE tools and resources. Namely, they pulled from a bunch of the different gene sets from the Knowledge Center tools, gene sets, and then they also used Enricher on the CFDE workbench. I figured I wouldn't necessarily have time to necessarily do a deep dive into all of these projects. However, we did record the final presentations of the hackathon, and it will be coming out in a visual podcast form soon. So if you really want to hear like a deep dive on all of these projects and what the final outputs were, you can check out that podcast. If you just want to kind of like poke around on the code and the work that was done, we also have GitHub repositories for all 5 of the projects. So you can check them out at the BioIT Hack 2025 repos. Finally, I want to sort of leave us with, some things that we learned and insights into, what went well and what we learned from this particular hackathon. So what was really neat to me was, in a way, at least, was, so one of the first questions we asked in the kickoff of the hackathon was, how many people, actually, I think it was Noel who asked this, how many people have ever heard of CFDE before? And almost nobody raised their hands. It was very few. But as she kind of listed off resources, like a couple more hands went up. But in general, like very few folks knew about CFDE at the beginning of the hackathon. However, obviously by the end of the hackathon, they knew, at least 6 resources, 7 resources that we talked about, right? Because they were either directly involved in presentations they heard from other teams, or tools they heard from other teams, or presentations that were talked about. So they really got to hear a ton about what CFDE is. So that's a huge success. Another thing that we noted is, so for some teams, they actually had physical representation from the DCC that created the data. So, for instance, for MotorPack, there was actually somebody from MotorPack on the team, and so like that team could pivot more quickly, explore data more deeply, and they got to have more of this like real time feedback back and forth. For the projects that were pitched that did not have leads that were from like the producers of the data, those were a little more slow to kind of figure out like data structures and how to deal with the data and to pivot when they would get stuck on things because they didn't necessarily have like a person to ask those questions to quickly. Um, so I definitely think we learned a lot from that. We also really noted that a collaborative computing platform would have been really helpful. We did have folks from AWS there, and they did give free credits. It took a little while to spin that up, and it wasn't necessarily completely straightforward to kind of ingest data from different places. So I think we would it would be very facilitative to kind of have a collaborative computing platform that has the data already on it and has a bunch of metadata on it, has tools kind of pre-baked, so that way they're like really ready to go. The other cool thing that we sort of observed, just because hackathons are awesome and open and fluid, we certainly didn't necessarily completely perfectly intend for this to happen, but representation from the Knowledge Center really meant that CFDE tools were utilized on the fly as needed, especially on that second day, because they'd already kind of on the first day you brainstorm, you kind of like have a general idea of what data, what question, and then the second day you're really like you're trying to code and do work, and so they had tons of like really deep technical questions about potential CFDE resources, and having somebody from the Knowledge Center to quickly answer them and have them pivot to using those tools, on the fly was something that we observed in real time and was super cool. And then at the very, very end of the hackathon, we had a quick question where we were like, just a show of hands, like how many people would participate in an event, participate in similar events in the future. And like 95% of people raised their hand and were really excited. I also just put, so we did do a feedback survey at the end, and we're not completely done analyzing those results yet, but I did just want to share a couple of fun quotes. So one of the questions was, did you get out of this event what you wanted to? And one of the answers was, yeah, I got to meet new friends and I got to code. So I'm super happy. And some people like that's what they want. They just want people in code, and a hackathon is great for that, and they're really excited. Another person wrote something a little bit more broad. They were saying, they said the projects were all interesting, the organizers were helpful, team members were friendly and knowledgeable. I learned a lot because I carried out this particular project. And then I just wanted to put a special call out to the Knowledge Center. Somebody explicitly said they liked the mini presentations, especially the ones about the CFDE resources. So yeah, that's kind of the BioIT world open source, fair data hackathon and hackathons in general in a nutshell. I know this is a bit of a whirlwind tour, but I wanted to leave time for questions if anybody had anything. But I want to also leave you with my favorite Douglas Adams quote, which I think is very apt for a hackathon because it is a little bit controlled chaos. And so the quote is, I seldom ended up where I wanted to go, but I almost always end up where I need to be. And if you want to look at any of the previous year's hackathons, they're in two different organizations. So one of them is in the NCBI hackathons. The rest are actually in a dedicated org for BioIT hackathons. Yeah, so thank you so much, and I'm happy to answer any questions. Maybe I'll stop sharing my screen.
Thank you, Alyssa. Does anyone have any questions? For those that want to ask the question using the video and audio, please raise your hand. I can give you the permission to talk, or please feel free to use the chat or Q&A box. Julie.
Yeah, I guess while we're waiting, thank you so much, Alyssa. That was fantastic. I can chime in from a personal experience. This was actually my first ever hackathon that I've attended. I am not a big coder or anything like that, but I loved it. I thought it was really inspiring, and I learned a lot from the participants and how they approach using these tools and addressing new problems. So, have you all thought about ways of taking what you've done this year with a CFDE based hackathon and thinking broadly about how we can extend CFDE into other communities, right? So we've talked about, I don't know, working with, say these other large data sharing initiatives, or thinking of ways of pairing data from different places, or thinking about how interoperable they are. Do you have thoughts on that?
Yeah, so actually hackathons have really become quite a thing in originally they were like very much like a computer science thing, and they've really come into a lot of like bioinformatics and even like data resource centers. So a lot of programs and data resource centers have started running these hackathons as well. So having CFDE not just run our hackathons, but also like pitching projects and bringing technical folks and things like that into other hackathons that are around related data or scientific questions and things like that would be great. Um, I mean, another thing is, so they these sorts of biohackathons that are also run with Elixir over in Europe and things like that. So if we want to get engaged more with those sorts of groups, potentially participating or offering even just like resources support. Sometimes I see hackathons that are running and I'm like, I don't need to be involved at all, but I noticed you're using this data and like here's some more data that's like very similar to this data in case because like a lot of times in hackathons they have like a resource guide, and so like sometimes just like having your resources be put on those guides can be really useful.
Thank you. Those are great ideas.
There's a question in the chat, which says, thank you so much for a wonderful presentation. This is super inspiring. If you could give any advice to yourself when you first started organizing hackathons, what would you say?
When I first started running hackathons, it was very much with the mindset of having like been a participant or a team lead. And I will definitely say, like as a participant, at least for me, like I love chaos. So like when I was a participant, I was like, I don't want anyone to give me anything. I don't want to hear any talks. I just want to like do chaos. However, like the more I run them, the more like if you notice, I now call them control chaos, and I have a lot more bounds and a lot more resources. We do like informational webinars, and we help build teams, and we build a lot of structure. So for me, like running hackathons, the biggest thing that I've really, I think, like learned is like where to find the happy medium, right? Like you want enough openness and enough unrestricted time for people to be creative, because the more you sort of put too many bounds on things, the more you put too much expectations, too many, rules, too much of this, that, the other, then it's just a workshop and you're just doing work as usual. But if it's completely open, oftentimes people will be like, hey, I spent like the first 2 days being like, what's even going on? What am I supposed to do here? Like, why am I here? Like, why are we all here? What's happening? And like that's not great, right? So you need to kind of have enough resources, especially because not everybody coming into a hackathon has the same tolerance level for chaos. Some people are very comfortable in chaos. Other people are, not so much. So like having as much resources as you can ahead of time too, because like some people love to prep and then they show up and they're comfortable, they're confident. Other people, like you could send them 10,000 emails and they're like, nope, I'm just showing up and it's gonna be great. So I think for me, like I definitely would have told my first, 2 or 3 hackathons I organized, like maybe a little more organizational structure is good.
Thank you. I actually have a question for you, Alyssa. So I know you walked us through BioIT World, the iterations since 2017. Is there any opportunity for a hackathon to go more than just one session? I know you talked about the marathon of a couple days, but has there been any instance, or would there be benefit if there were potentially multiple sessions per year spaced out? Is that something that normally happens, or is that a little too much of a marathon in that sense?
No, so actually, we did that when I worked at NCBI. We actually had multiple hackathons in a year, but it was all kind of surrounded by SRA data, but it was different data types. So we ran multiple that year, but it was sort of like, okay, we want to look at, everything on this data type, everything on this type, data type, everything, and then kind of see if we can iterate and tie it all together. We've also done things in other programs where we do hack days, and so basically like once a month for like 3 months, 6 months, even a whole year. But it's just like one day a month. It's the same day every month, and then we kind of like build and iterate and things like that. We've also had events where we sort of have like one at a conference. We'll have one that's almost like asynchronous, where it's like let's just throw out ideas and like get that, and then we'll have one that's like smaller and very focused. And we're like, okay, these ideas worked, these didn't work. Like now we're going to iterate on like just this smaller set of things. So yeah, you can use them in an iterative model. You can also use them in sort of a broader programmatic context where, for instance, I've done this with so Howard has this VATSD program where they have this virtual program to sort of like build data science skills. And so they have like very structured workshops and lessons each week. But at the very end, like we know from how people learn and how people sort of like retain information that like there's only so much you can kind of get with very like specific guided approach. At the end of the day, you have to apply it to a new question or it doesn't quite stick. And hackathons and like that project based work can be a great way to kind of cement new knowledge. So you can actually kind of stick it at the end of like a bunch of like very, hands on but structured workshops. And then at the very end, like tie it all together with a hackathon. You can also partner hackathons with things like challenges. So, for instance, you can run a hackathon first to be like, what are all of the potential solutions? And then maybe two or three teams, like you're like, ooh, that's a really good idea. And then you take just that idea and you're like, okay, now it's a challenge. Give me the best solution for this one idea. So you can kind of use this in combination with other events too.
Thank you. Any other questions? Go ahead, Julie.
Yeah, one more from me. So how much work have you all done in, say, partnering with more individuals in, say, like the pharma space or some of these other spaces outside of these open access resources to crowdsource? Okay, we have all these accessible resources, but now we want to work on translating them in a different sort of industry-based context or something like that.
Not for this particular one, but I have done it with other programs I'm part of. I will say like that is a little more of a tricky dance, because at the heart of it, like hackathons really are meant to be like very open, right? Like all of our stuff is on GitHub. You can look at it. It's chaos. Um, but I mean, a lot of the times, especially at BioIT, like there were a ton of folks from industry there, like participating on each of the teams. So that can be kind of at least the first step in that conversation. Like, hopefully, like some of them are like, ooh, this is really cool data that we could use in X, Y, and Z. Like, we would like to partner with you to do that. So that does happen, especially like the more you kind of like keep showing up to the same place and then keep showing up with like new stuff and then they're excited and they want to engage with you.
Great. Anyone else? All right. Well, thank you so much, Alyssa. I greatly appreciate that. And it's exciting to see, where we can grow from that moving forward as well. We're very excited to see more of this moving forward. And just a reminder to everyone, our next webinar will be Friday, May 30th. And this is going to be recorded. So if your colleagues weren't able to attend, please feel free to share them the video afterwards. And again, thank you so much for participating. And we thank you again, Alyssa.
Thank you so much for having me. Have a wonderful day.
Bye, everyone.
Bye.